In the last segment, we talked about how to transform the stress or the state of stress from one coordinate system to the other, or we also discussed about the fact that it is equivalent to saying that you are considering basically a rotated element, and on the surface of that element you are now talking about the stresses. So that is what we discussed, and if you remember, I told you that the motivation for doing that is to see where we are getting, or where, in the sense, at what angle, if I turn the that elemental square or the cube, I will experience the maximum stress, because that is the plane on which it is highly probable that it will fail, the material will fail, because the stress will be maximum. So, with that intention or motivation, we derived that mathematical tool or mathematical equation through which we can actually transform or see how the stresses are changing as we change the angle theta of the orientation. So that means in this segment we are precisely going to discuss about those maximization of the stresses, and they are named as the principal stresses, and the maximum shearing stress. So basically these are the things which are of prime importance to us, and in view of finding these stresses we did all the things whatever we did. So just to have a recap, I have kept these things from the previous segment, that so this is what we had done. So sigma x, sigma y are the stresses. So again I'll just take a minute to recap about what these things are. So sigma x, sigma y are the stresses, and tau xy are the stresses which you have in a way measured. Okay, I am saying measured because it will give you a feeling that okay, from where are we getting these things and what are these, okay, but not necessarily that you have measured it. Okay. So then suppose you have measured sigma x, sigma y and tau xy in some specific direction by putting the strain gauge rosettes. Okay. Now then with respect to that axis, so that axis is now called our xy axis. Okay. So that means if so this, like here, so this is the picture. So this is sigma x, sigma y and tau xy, and so this is x and this is y, and with respect to that, now if we are turning the elemental square by angle theta, and that we are calling the axis x prime and y prime. So under that or on the surfaces of that rotated or rotated square, these are the stresses which will exist. So just if I want to draw that, so if I just draw it like this, so these are sigma x prime, sigma y prime, and these are tau x prime, y prime. So that is how the things are, and this is the angle which is theta. Okay. So that is the whole story which at which we stopped the previous segment. Okay. Now if you observe, it is actually difficult to observe, but just imagine that here in these two equations, if you see, this theta is a kind of parameter which expresses these two values. So, is it possible by some means that we can eliminate this theta so that we can get a relationship between them, and let us see how it looks like, because in some cases it is possible that some nice kind of curve may come up. In fact, it will come up to be a circle. Okay. So, that is what is the thing. That means we will see now in a moment that these are the parametric equation of a circle, that means, and then with a parameter theta. So, in fact 2 theta. So, if we remove these 2 theta things and get a relationship between them, we will see that it will become a circle. So, what does that mean? It means, just a minute. So let us see. If you, sorry, if you evaluate the sigma x prime minus sigma x plus sigma y over 2. Okay. So, after the process of elimination of that parameter 2 theta, I am just writing the final expression. So, its square plus tau x prime y prime squared. So, this will be equal to sigma x minus sigma y over 2, its square plus tau x, so tau x y square, yeah. So, this is what you will get. So, now observe things which are important. So, here this is x primed, y primed. That means from these equations we took these two, okay, these two, and we are calling a point, say M, whose coordinates are, say, sigma x prime on the x axis, that is the abscissa, and say tau x prime y prime is the ordinate. Okay. Suppose that is how we try to trace the points by eliminating theta from this, then you are getting this expression. Now, obviously this is the equation of a circle which looks, and then if you see the y coordinate, that means the center of the circle lies on the x axis. Okay. So, if I would like to draw something like this. So, the x axis we say is sigma x prime, y axis we said is tau x prime y prime. So, this equation will trace basically a circle, okay, whose center is this. That means it's the sigma x plus sigma y over 2, or what, in terms of, if always we will try to, for this segment of discussion, we will try to correlate all these things with respect to the measurement by using the strain gauges. Okay. That means when you measured with the strain gauge the sigmas, so you got sigma x, sigma y. So, the average value of that is the center, and the radius is this. So, this is the radius of this circle. Okay. So, that means you go to the point on the x axis proportion to the value sigma x plus sigma y by 2, that is the average stress, the average normal stress that you have measured from the strain gauges, and then you have also measured the tau xy. So, from there you calculate the radius, and then you draw the circle with that being center and this being the radius, and then all these points on this circle will give you certain values of, for example, this point. If we say this will correspond to, this is a very bad drawing. Okay, so maybe this. Okay, so this is like sigma x prime of a point, and this is like, you know, tau x prime y prime. So, every point on this circle corresponds to some angle or some rotated elemental square on which we are seeing the stresses. In fact, there is no, let me again draw that square so that I can talk about it referring to this. This was our original, if we call that original. So, this being sigma x, this being sigma y. Okay, and on that, if I draw, say, the picture of rotated thing, this being sigma x prime and sigma y primed. Now, there is no specific preference for this axis than this axis. Only thing, if we have measured certain values by putting a strain gauge, then obviously this axis means more to us, because we know that on the actual physical situation there is a direction in which we had put a strain gauge, and that obviously will feel like our original x axis. Otherwise, these points are like, you know, all are very similar. Every orientation has got its own right, so to say, so that there is no difference between, difference is not the word. What I want to say is no preference of this axis over this axis. So, that means on this circle somewhere this point also will be there, where you will find sigma x and sigma y. Okay, maybe that will come at this point. Let me put that on some other color. Maybe at this point you will find out that the sigma x and what is that, tau xy point is there. It's quite possible, because as we move on this circle, basically we are moving on these rotated elemental squares, and we are seeing the corresponding stress values, okay, sigma x and tau xy. So then we came here to see two important things, that is, what is the maximum value of normal stress which is happening, and what is the minimum value of normal stress happening, and what is the maximum value of shearing stress happening. Now, from this picture, it's very easy to now see what is occurring. For example, if I tell you to find out what is the maximum normal stress that is happening under this condition. So, obviously, this is the maximum normal stress that can occur, and similarly this is the minimum. So, I will say this is sigma max, this is sigma min, which can happen, and then we do not know in some angle or in some square oriented at some arbitrary angle, but the value of sigma max and sigma min will be this much, okay. And similarly, the maximum shear stress is at this point, right. So, this is tau x dash, I'll say tau max, okay, not, so tau max. So that is the maximum shear stress which will happen. Now the thing is, to get the in a way angles at which these things happen, you can do one thing. For example, we will just go to these expressions. Oh, sorry. For example, this one, okay, just see this expression. Now this corresponds to or else, that's fine, yeah. So this expression, where did I go? So here if you consider where sigma max is happening, on that point tau is 0, right. So you are getting the maximum amount of normal stress at a location either here or here, maximum minimum. So that's happening when your shear stress is 0. So if we substitute this as 0, we will get a relationship from where we can actually calculate at what angles those two surfaces will be, this max and min, how what will be the relationship between them. So if we put that tau, sorry, not this color, it's say tau x prime y prime, if we put 0, we will come to the expression that tangent of 2 theta will be equal to 2 tau xy over sigma x minus sigma y, right. So just see it here. So this is one, so you took it this side and tan of 2 theta is that over this, okay. So am I missing? Yeah, take it, right. Okay. So this tells you what? That means, see, the sigma max and sigma min are the stresses which exist on planes which are, you know, which satisfy on the planes which satisfy this condition, okay. So just it's a bit tricky, just think about it. Suppose this is the point where you had measured your sigma x, sigma y. So now with respect to that, you are going this angle theta to come to a stage where you will figure out or find out the maximum normal stress. Or if I want to draw a picture, say here was the x axis, and now you have rotated this square by some angle theta to get x prime, and this angle theta is this, and on that it is now so I'll put that it's the sigma max, okay. So that's what is the meaning of this equation. That means from tau xy, or the original coordinate system, xy coordinate system, if you rotate it by similarly I can draw even the, you know, the y axis. So y axis for the original was here, and the y axis for this new configuration is here. So again this is theta p, okay. That means from the original location or original orientation, on which, when I am saying original, you can always map it to the direction in which you had put the strain gauges, okay. So from the original orientation, if you turn by theta p, you will come to the orientation on which the maximum normal stress is occurring. But then one more point to be observed is see, theta movement on the actual location, actual physical location corresponds to 2 theta on the circle, okay, because here we are moving theta, and at the same time we are moving 2 theta on the circle, because that is parameterized with 2 theta as a parameter. So that means this 2 theta, when it becomes a again it will get the same value in say 180, after 180 degree, it will give you